Okay, I think with that we are roughly on time. Still see people streaming in, which is great as always. That's why we record these. But we'll go ahead and get started just in case we want to ever cut these later for video purposes. I'm going to do a quick pause and then we'll dive in. Welcome to the first coffee break of 2023 on January 11th. My name is Andrew Miller, Principal Technologist at Pure Storage, your coffee break host. Joined today for the second time. Thank you, Brian, for joining again. So it's always great to have a literal rocket scientist back on. A little bit of housekeeping. As you know, hopefully, this is a series, as indicated by the cool logo. We are now literally into the second year of Coffee Break. So all of these are aired online. You can find the recordings later. And they've actually aged better than average, I think, due to the solution focus. You know, we talk about Pure stuff, but it's in the larger context. You can also find them on purestorage.com/event center. It covers both the coffee break and our flash crew, our customer webinars, our tech talks, or more kind of specific technical webinars on previous ones there. Last but not least, in housekeeping, in case part of your motivation, or maybe all of your motivations coming from the coffee, a little bit of revision on this that we've changed. Actually, it may or may not be Starbucks, depending on where you're joining us from. And I was remiss of not changing the slide before. A couple months back, we started to shift this over to business emails only. That's because of how many people are joining us. And in some cases, there might be clever folks out there that are doing multiple registrations. I applaud the effort, but I think you understand how the game works here a little bit too. So if you don't see your coffee card, make sure to double check your spam filter. That into introductions. As always, I am your host, Andrew Miller. Appreciate you joining us today. In the past, and while I usually try to say as much of my background, when it relates to energy, I actually remember the first time and being responsible for a data center and actually understanding how the HVAC worked and the power that came in and actually the UPSs that were huge, and even the UPS tech that one time might have knocked the UPS offline while he was servicing it. It got eerily quiet outside my office when that happened. It was like, I've never heard it sound not like that before. I'm joined today, though, by Brian Gold. Brian, do you mind introducing yourself again? Since you did a year ago, but please.
Yeah, it's great to be here, Andrew. Thanks for hosting, as always. I'm Brian Gold. I'm a VP of Technology here at Pure. I've been with Pure Storage it's coming up on 10 years, so quite a while at this point. Never thought I'd actually work anywhere for 10 years at one company. It's kind of weird in the modern, certainly Silicon Valley era, but it's been awesome and a lot of fun. I have a pretty varied background from academia back in Pittsburgh and a few other places in and around the Bay Area. And yeah, it's great to talk with folks about some of the really deeper technology stuff that we're working on here today.
Congratulations as well. I think since you last joined us, as we were talking, it sounded like your job responsibilities changed dramatically, but you're now listed as a VP. So, congratulations.
Good for you. Whatever that's worth. Thank you.
As well, please make sure to join us next month. I'm going to be focusing back in on VMware. Like it says, VMware and Pure, we're not done yet. It's a little bit of an allusion to we've been doing so much with VMware for so long, as they've been doing stuff with us too. There's new good stuff that we've been doing, and there might even be some fun stuff you haven't heard about that we're going to touch base on. So last time with this topic, Cody Hosterman joined me. This month going to be joined by David Stamen. He and I actually had the pleasure of presenting at Tech Field Day Extra back at VMware Explorer last year. So we'll be diving into all things VMware and Pure. But with that, into the topic. Now, it was kind of fun to do a little bit of brainstorming. I want to give kudos both to yourself, Brian, and to Jeff Pickett, who's joining us and manning the chat and the Q&A line there, kind of thing, about, how do we approach this topic? Because we do sometimes see in the industry just a lot out there around energy savings and efficiency and everything's simple and everything's better. It's like, can this actually really be true? And is it a focus? Now, what we wanted to do to this month is not do the same thing that we did last month. We as Pure, that is. So we had a great webinar last month with Kevin Rickson, Don Kerouac, where we went into kind of all things energy savings focused. Even thinking about, you think about stuff like you look at Northern Ireland, like the government has said we can't build more data centers there. This is getting discussed, especially outside the US, but especially with the larger customers that I see in the US too. But you might see sometimes claims like this, and this was kind of the centerpiece of that webinar about, 84.7% lower energy usage. And it can almost maybe sound too good to be true, right? That's a pretty dramatic number. So we were trying to think about how do we take a kind of coffee break-ish approach to this and really focus in on the answer. So what we wanted to do, we're into the agenda. You're like, where's the normal agenda slide? Here it is. So please, like it says, let the energy claims be more than marketing. So we're right after Christmas. So like I watched various Christmas movies over the years. A recent favorite is Polar Express, right? Polar Express, like I want to believe almost that sense of being a child, believing in something more and even something transcendent. But in this case, like, can it be more than just claims? So that's what we wanted to explore. 4 parts, as always. First, wandering into kind of the history of Flash a little bit and what we've seen in the industry. Is Flash just a flash in the pan, maybe? Second, really actually go into the physics. This is especially where I'm glad to have Brian here, because this is where I've said this before, hopefully not too awkward, the professor that you enjoyed listening to kind of thing, as you walk through some of this. Third, 2 + 2 = 5. Is it a hardware discussion? Is it a software discussion? Why, yes, it is. And last but not least, how do we actually then think about, if we think about things at a very micro level, what about the macro level? What about petabytes to exabytes? Are there principles that can apply here? So with that, I think, Brian, if I'm not mistaken, we were going to actually kick off the first poll here, if you don't mind, Emily. So just in reference to the topic of energy consumption, because that's what we're going to talk about today, where we're going to kind of orbit around it and even go really deep there. So I'm just going to leave this poll up here for a minute as we kind of kick it off. So as we think about this as a topic, Brian, and especially 10 years here at Pure, all of this working heavily with Flash and designing storage systems, is both as Pure and maybe even as an industry, is kind of this energy topic and energy stuff new? Been there for a while, different ways? Help me out there. What's your perspective?
Well, so it's certainly been around. And if you go back actually 10 or 15 years ago, it was peripheral to energy overall, but there were big calls especially in the build out of kind of hyperscale web architectures, things like Google, Facebook, Amazon, and so forth, about what was called energy proportionality and power proportionality. That if we put a kilowatt into some bit of IT equipment, how much utility do we get out of that? And that's something that as we built hyperscale data centers, it mattered a lot. And you had kind of a single platform that would derive benefit from that efficiency. And so it got talked about there, but what's happened over the last 10 or really 5 and even 2 years is that's come more and more to the forefront. And you've seen it, whether it's the rise of virtualization and moving from physical servers to virtual servers to get higher utilization and higher efficiency, or the changes in networking to have more efficiency. There's a common theme here of energy efficiency is actually a story of just efficiency. General. And that can be great because it serves the dual requirement of lower my costs. If I'm more efficient with the IT equipment, I'm going to consume less energy, hopefully, and I'm also going to spend less money to get to an outcome. And that, kind of win-win scenario is something we've thought about, basically every day for the last, 10, 12 years here at Pure.
I even think about the density. I mean, we didn't even talk about this before. Like the first time that I started to do heavy stuff with UCS and UCS chassis, like server chassis or blade chassis, and you couldn't actually fill up the rack anymore because you couldn't get enough power into the rack because you made it so dense already, kind of thing, thanks to VMware and other stuff. So maybe even focus it on storage. So with storage, we've kind of spent maybe a decade throwing SSDs or NAND at this, but not necessarily for energy reasons, though, right?
Yeah, you look at the cost of flash 10 years ago, and it was clearly a premium relative to spinning disks. And so for especially really large scale data sets, you'd say, well, okay, I'm physically rotating something and it's not the most energy efficient thing to keep something spinning at 7,200 RPM or whatever, but it's really cheap and I need a lot of it. So for certain use cases, you're stuck with it. But 5, 10 years ago, and certainly still today, anything that needs performance, I'm looking at flash. And we've seen the rise of all flash storage systems. We've helped be a part of that with what we've done at Pure. But there's always been a performance element to that because flash, has that associated, cost premium associated with it. And so, today's especially really large scale platforms still have a fair bit of disk in them. And that's, in some ways where the next area of our attention can focus on energy efficiency, because we got to get rid of these spinning things if we're really going to drive down power consumption for storage systems. And if we can do it in a cost-effective way, then we get that win-win of energy proportionality and cost efficiency.
It is this perfect storm of, I think we've all heard data is exploding, whatever the numbers are, 3x per year, 10x per year, say zettabytes are big numbers. At the same time, that the energy pieces around that and even the physical aspects of the data center. So if we look at that then through a little bit of a cost lens, so there's a piece of kind of why all flash and all now. And I think you said you have this chart actually printed on your, and it's like stuck up on your office wall, if I'm not mistaken. Like, help explain why that is.
Well, we think a lot about trends, and it's helpful to look at long-term trends, both historically and projections going forward, to understand the decisions and choices we make in building a product or designing a large-scale system. What are the big macro forces that are, we're working against or working with? And so this data is actually publicly available data. It's really fantastic data set that looks at consumer prices going back, for some components, actually goes back decades. There's a professor who's been keeping track of consumer prices for electronic components and publishes this regularly. And so in particular, we've normalized everything here to $2022, factoring in, various, inflation over the years. And it's looking at dollar per gigabyte of just hard drives and SSDs. And you see, kind of we've put in some trend lines. We see a slow convergence there, and we're getting closer. And you can see the path we've gotten with flash components, using SSDs as a proxy for that. It's getting us closer, but we still got a little bit of a gap here today. And part of our mission is to help close that gap.
I want to make sure to put in, because there's some stuff, when you and I were talking stuff, we don't want to put in too much preface stuff. We want to just like dive into the stuff. But fundamentally, the energy usage, just by using flash, is a good bit lower than hard drives. Although there are definitely challenges there in trying to close the gap. So back to you.
Yeah. So, we want to build cost-effective systems. They've got to be resilient, reliable. I saw a question come through quickly in the chat there about longevity. We'll talk about how we handle that. That's a huge focus for us and for anybody. But there are things just on a cost front that we as system builders can do to close this gap that exists at the media level and get all flash designs that are cost competitive with hard drive based designs. And it's things like, well, continue to adopt the latest, greatest, cheapest NAND. Today that means using QLC media. It'll be PLC, here in a couple of years. We've got to have really efficient parity. How do we encode resiliency into a system? Something we've put a lot of time and effort into at Pure is having best-in-class data reductions, so that if there's any redundancy in the information you're sending us, we can squeeze that out and need fewer physical bits on the back end, so on and so forth, to get really, really cost-effective systems. But
I did it just right. But keep going.
Not so simple.
Yeah,
and in fact, that first thing I mentioned there of keeping pace with where flash is going at a technology level, it means that the cost of NAND goes down, but we've got to address the endurance problems. And as folks who are familiar with any of this part of the technology landscape may know, as we store more information per cell and as we make those cells smaller, we tend to have worse endurance characteristics. And we'll talk in depth about why and how we overcome that. But that's actually just the surface level problem. There's actually many problems in the NAND. And this is the full chart I have printed on the wall to think about. The problem is actually worse than you might think, because one of the solutions you can apply to try to overcome some of these NAND issues, you can put a bunch of DRAM in a system and do caching. But DRAM stopped scaling in cost curves actually a few years ago. And there are dips and valleys based on supply chain and some technology trends, but it's basically flat. And that has huge implications on how we'll build systems. And so all of this we say is just context for, we wake up every day as, architects here at Pure at least, and we think about how are we going to build future storage systems for a huge variety of use cases, some of which may be very performance sensitive, some of which might be more archival and capacity optimized. And we've got to take all these raw components and build really, really efficient systems out of them.
So doing that requires fundamental understanding of what the building blocks are: DRAM, NAND, hard drives, etc. I'm going to do a quick pause. Let me close the last poll here, and we'll share it back with everybody. Hit the share results there. So it's interesting to see 50% of folks saying energy consumption is much more important. 40%, it's about the same. And 10%, I think you'll find the rest of this interesting, right? For other reasons. But at the same time, it's not. So actually, that trends, and even in some cases, we see different distributions from core company size, because that affects total energy bill, even geographies, US, EMEA, APJ, et cetera, kind of thing. So as you mentioned, this is not, the problem is worse than we might think, but to even kind of understand that, and I got out of order. Emily, could you launch the second poll here? As you can tell, we planned this out, but not precisely. So second poll coming up right now. We'll let this sit out there. And actually, so yes, okay. So this is a little bit similar, sustainability higher than it was before. So we'll let that one sit out there for a minute. I won't read the poll. We'll come back to it. So we think about then, what are the building blocks that we truly have? Because in a way, we've had SSDs, we've had flash for a while. And some of what I really enjoyed in this, Brian, is just how you go all the way down into how it really works. So do you mind walking through almost just like at a physics level?
Yeah. Well, so first, a little bit of why, right? If we really want to solve these macro problems, we got to understand at some point, we need to understand how everything works. Even if, we at Pure Storage or other system builders and system architects, we might not be fabricating the individual NAND cells or chips, but I need to know the properties that they have so that I can factor in where they're going and what we're going to do about some of the challenges at a system level. And so I've enjoyed learning and talking to real deep experts on the physics of flash, and then thinking about how are we going to work with those. So here's a quick primer on how flash works way down at the electron level. And so the picture on the left here is a transistor. And if you've never seen something like this, don't worry, it's really not as complicated as you might think. Think of it like a light switch. And what we do with a transistor of any kind is we apply some voltage, some effort across the top and bottom. That's like flipping the switch on. And if I apply a certain amount of effort or voltage, I'll switch this switch on and current will flow. What folks back in the 50s figured out was if we apply a lot of voltage, like kind of a crazy amount of potential across that top and bottom gap, it will actually cause a physical effect called quantum tunneling, where these electrons that are flowing from left to right in our transistor, they will shoot across this insulator gap through quantum tunneling, and they'll get trapped. And that's kind of what we have shown in this cartoon, is these little circles. Think of these as trapped charges, and they'll stay there. Even when you take all the power away, they'll stay there, and which is kind of an amazing physical property. While they're there, though, and they're sort of there in mass, there's a bunch of charge, they change the electromagnetic field, and therefore they change the amount of effort it takes to turn the switch on. And that allows us to now understand whether we've trapped those charges or not. And that's what the graph on the right shows. If we have thousands of these transistors, some with trapped charges and some without, we can actually observe which group is a given transistor is in based on whether this electromagnetic field is disrupted. And if we can tell that condition? Well, we can call one of those states 1 and the other one a state 0. And congratulations, we've just stored a single bit of information.
Binary, all the way back to binary.
And if we can tell a lot of charge, or if we could tell a lot of charge from no charge, well, maybe we could tell some charge from a little less charge. And so if we have the ability to differentiate 4 different levels, we can actually store 2 bits of information. And if we can tell 8 different levels of charge, we can store 3 bits, and so on, to get all the way to what you can see in production today, where we can store 4 bits of information. So that's 16 different levels, which, if you step back and think about it, is kind of amazing, that we're harnessing all this sort of underlying physics, and we stack these things up in these incredibly sophisticated, 3D stacked die. A petabyte of information is quadrillions of bits, all stored and using this sort of quantum of physics effects. And we don't think about that every day necessarily as we use storage devices, but it's pretty amazing stuff. So, but
it's amazing. Yeah.
But there's no free lunch. And as we mentioned up front, endurance has long been a concern with flash, and it gets worse. And so, the way to think about this, now that we've kind of introduced this idea that, hey, we have these different threshold voltage values we want to tell the difference between to be able to store and retrieve information. Well, we kind of wish they were these perfectly divided, and I could tell, this many electrons is this value and this other many electrons is other value. But in fact, the different distributions have some overlap, and it's actually even worse than that. They change over time. So as we write values to this, they change, the distributions drift and degrade, and this is a visual of what we know to be true of the realities of NAND, is that it has lower endurance, and every time we pack more information in or we make it more dense, it gets worse. There's all kinds of quirks and caveats that we as system architects have to deal with, because they are tied back to these physical properties of, like, quantum tunneling is literally smashing electrons through tiny microscopic, films of glass. And so you end up with, a trend over the last 10 or 15 years as we've gone from storing a single level cell, single bit of information, to the modern quad level cell flash, where we have, roughly 100x fewer write cycles. And when we do a write, it takes a long time. It takes like spinning disk latencies to erase or write new values. And those have huge impacts on how storage systems should be built.
So from a general, and whenever I've looked at this, and I'll talk about this, this is dramatic. We're talking order of magnitude shifts, 2 orders of magnitude shifts as far as the endurance. There's actually a great question already from someone about endurance, right? That is one of the key things we have to solve for. So at a general industry level, we're kind of still leaving Pure out of this in a way, although we think about this topic a lot. This is a more educational, agnostic type content. How have SSD vendors solved this in general?
Well, so the first thing we want to do is run away and hide. We want to, as consumers of flash, we want to pretend none of this stuff exists. And in fact, even the basic programming challenges of the fact that flash, you can't do random overwrites. You have to do what are called out of place updates, where I can only erase this block of cells and then append new information into it. And so what we do is we create an illusion layer in an SSD. We create an illusion layer that says, don't worry, pretend this effect isn't there. We'll have what a traditional hard drive would present to you, which is this linear block address, where I can do random 4 kilobyte sector level overwrites. And it's the job of the SSD, through the flash translation layer and all of its machinery inside of the drive, to hide the physical effects and to remap that logical address space into the really complex underlying physical structure. The problem with that is that illusion layer knows nothing about the file system, your application, your database, your VM environment. It knows absolutely nothing. And so it's stuck basically with a set of heuristics and designs that are more or less designed for arbitrary, random, workloads you might find on a laptop or a phone or in a data center. And it's really hard to be good at all of those things and yet know nothing. And it gets really expensive. And to tie this back to even the energy and cost efficiency discussions, all that illusion layer that we're keeping in these drives, in these off-the-shelf SSDs, well, it takes about, typical rule of thumb is you have about 0.1% of the flash capacity you'll have in DRAM to keep these mapping tables of mapping logical addresses to physical. And that might not sound like a lot, like 0.1%, but we're seeing storage systems that are now pushing 10, 100 petabytes in scale. Well, a 10 petabyte storage system has 10 terabytes of DRAM inside the SSDs. That's not server memory, that's embedded DRAM. And remember that earlier chart that showed that DRAM is not getting cheaper. So it's really expensive and it draws power because you got to keep it refreshed all the time. And so it's quite inefficient to do it that way. And so the problem here is that the SSD, being kind of a black box to outside software, it throws away any knowledge that might have existed in the file system or in the database or in whatever application you're running about metadata updates, different types of write streams, different background tasks that might be happening, and it has no knowledge. And so we got to burn all this DRAM and power budget to support what might be a laptop-oriented workload, even though you're running some VMware or SQL Server or Oracle or whatever in your data center.
Yeah. Well, it's fun talking about this. I mean, is that it's amazing this works at all. You talked about quantum tunneling, you talked about like applied physics, like the modern SSDs. Didn't just make it on the slide. I mean, and you wrote this slide actually. I mean, they're engineering marvels, but there's a lot to go further.
Yeah, they really are. And it's a testament to the industry and how much opportunity solid state presents that, there's enormous R&D investment has been made. And if you don't know anything about the workload, it's hard to do better than an SSD. But if we're building, petabyte scale storage systems for data center type workloads, we do know a lot more and we got to go further.
So we're now into, how do we think about this as Pure a little bit? And we're still orbiting around, by the way, everything. This is energy. Yeah, we kind of were going all the way down, then we're kind of pulling it back up again. So like this is like how it truly all works all the way down. Because I mean, NAND fundamentally more efficient than spinning disk, but then there's challenges with it. NAND, flash, is term interchangeably. So how do we develop solutions about this? And this even goes to the idea of, I first saw this quote actually on a Steve Jobs presentation with Apple. And I know I'm giving free advertising to Apple, but well, so be it, kind of thing. The quote from Alan Kay of people who are really serious about software should make their own hardware. That is what we're kind of alluding to here. 2 + 2 = 5, or is this a software question? Is it a hardware question? It's both actually. That's what we've done from a Pure standpoint. Think about how do we co-design these two systems. Back to you, Brian.
Exactly. So if we are the designers and architects of the software that is implementing a file system, an object store, a large scale storage system, even if it's presenting, block abstractions, we know so much more than you would if you were building an SSD. So we want to take advantage of that knowledge that we know all these different write streams, and we want to design the structures in the hardware and the structures in the software. And so this, picture on the left, which, we needed like another hour to talk about the data structure fundamentals. So we'll skip some of that, but rest assured there's a lot of work that's been done to design really efficient data structures to represent all the complex metadata. And we're going to co-design those structures with the hardware that we're also building on top of the underlying media, such that we get all the context and knowledge of what's going on in that higher level software, but we also have direct control and visibility into that hardware and into that media. And that's the key enabling insight, if you will, that we can use to overcome some of the really big technical problems that exist in modern flash and in building efficient systems at scale.
Especially when it comes to energy savings. So there's three, I think there are three areas that we wanted to highlight there, kind of both benefits, but also problems we solve. First, around lifetime, right?
Yeah, so we hopefully made it clear that, we've got cheaper and denser components that have come with modern flash fabrication technology, but that presents an enormous endurance problem. So how do we overcome that? Well, the key is get rid of that illusion layer and have that context, have all of the knowledge of the different streams of write activity. Our software, which is called Purity, now understands what those different streams of metadata and data, and we can place and align that data onto flash in such a way that we minimize what's called write amplification, so that we're not having to collect as much garbage and rewrite things on the back end when you as an end user didn't actually do a new write. And so if we can minimize that write amplification, we can extend endurance no matter what the flash technology is, under the covers. Minimizing write amplification is a good thing. And this graph shows, really the ultimate measure of that, which is annual return rates. Think of it like an annual failure rate, effectively. The blue bar, so lower is better, right? We want to get fewer things back that fail. You want to send us fewer things back. The blue bar is kind of your SSD typical number. And as we built a software system in the early generations of flash array. So this is the FA300 and FA400 series, where we were using off-the-shelf SSDs, and we were better than kind of the industry average because we wrote the software knowing it was flash, but we were still working through that illusion layer. And when we moved to our direct flash modules, that's that co-designed hardware and software, we saw roughly a 3x improvement. And we've been able to make it better by collecting some basic telemetry from call home systems through Pure One, where we can see, hey, how do we improve some of our heuristics and algorithms to do that scheduling and placement in a way that reduces write amplification and further extend the lifetime of these devices. And this has held up phenomenally well for us as we move from MLC flash to TLC flash to further generations of TLC. And we've now got multiple years of production experience with QLC, and we see really no end in sight for our ability to overcome these problems that are plaguing the rest of the industry.
Efficiency, lifetime, that's what underpins actually Pure having, flat and fair maintenance, because we actually know that they'll last longer. But flash is still about performance, right?
It is, and we can't give that up as we move to the latest generations of flash. And so a big way in which we overcome these longer program and erase times is by doing fewer writes. So it's actually a side effect of having lower write amplification as we get some performance improvements. But we also have, by engineering these systems end to end, we have the ability to use NVRAM and to use the right amounts of DRAM caches such that we can mitigate, we can't eliminate, we can mitigate some of these tail latencies. And at the same time, avoid just throwing hardware at the problem, which is going to increase energy costs and is going to increase just actual capital costs. And so a big part of what we've been able to do is take a lot of the DRAM out of the drive, consolidate it, pool it, use it more efficiently in the whole system. And that's really allowed us to unlock the scale of what you're seeing already in the market with the direct flash modules, where today we've got a 48 terabyte DFM that's based on QLC media. And while I can't, unfortunately, give you precise, my legal team won't allow me to give you precise dates.
There's more coming.
There's some exciting stuff happening in our future over the next couple of years where we're really going to see massive increases in scale. And we'll use this to serve different parts of the market. We will continue to serve the really high performance parts, but we're likely to be able to serve an increasing number of more capacity centric. We're already doing this with the FlashArray C and the FlashBlade S platforms, and we're just going to keep pushing further and further because that intersection, is across all of our products now, and that intersection of software and hardware, it's what I came to Pure to do. I have a background in hardware, but always have worked kind of right at this boundary level. And it's a fun place to be. You can really affect big outcomes when you control both sides of that. So it's been pretty awesome to build this out here at Pure.
To kind of highlight a little bit. So for those who are joining us partway through, key part here is Pure doesn't use SSDs. We actually build the equivalent. Even there was actually a great video with I'm free on the YouTube channel, called actually the whole array is like one big SSD almost, if you will, because it sees and understands everything. I think, Brian, you were saying like it's 500 engineers that are basically behind this one slide that are working to make the things on this true and not just marketing.
Yeah, 500 engineers, 7-8 years, no big deal. One slide gets reduced to one slide.
But there is, like it said, this is the short version of what we walk through, and even the density, 49 terabytes today with QLC. This is where we're going all the way back to the title. The answer is truly better science. Like, we're not making this up. We've actually had, 10 years of engineering. That's part of why we say 10-year head start on competitors that have just been using SSDs off the shelf, if you will. But by the way, we've actually been thinking about, this will actually be a final poll question. There's other topics that we could do that are truly like better science and engineering beyond this direct flash topic. We may come back later and do some other coffee breaks on this. That'll be a later poll. I think we're at the end of section 3. We're roughly on time. I was kind of cheat back and forth a little bit. I'm going to close the poll here and then share the results back with you. Thank you, everybody, for answering. We had about 1,200 people answer, which is pretty amazing. So if you or your company specifically designated energy savings or increased sustainability as one of your top priorities for 2023, 63%. Yes. So that's interesting to kind of map that even to the previous poll a little bit. I won't spend too much time playing with those thoughts right now because we got one more good section to go to. Now, section 4, but even before we say what it is, what if we've been all the way down here? I really appreciate how you walk through it, Brian, because to me, it's very understandable, but we've been all the way down at this layer. What if, though, we solve the micro, we do all these amazing things, but we miss the macro? We're in data centers. We've got stranded capacities and arrays that aren't running. Well, because we need to avoid stranded capacity, performance and capacity-wise, or stranded resources, either performance or capacity. But we can't get too close to the red line or else things fall over. So we need that magical, it's almost a Goldilocks thing, not too big, not too small, just right, kind of thing. So this is where we go into thinking about, if we're thinking about this through an energy efficiency lens, this is part of what we do at the micro level. But is there stuff here that we can do and think about at a macro level, at an exabyte level? And this is where, Brian, I love how, you have conversations that wander all the way to that scale as well, right?
Yeah. And so whether you're building an exabyte scale private cloud or even a much smaller, so if it's petabyte, type deployments at a smaller shop, what we've seen over the last, really few years is growing complexity is becoming as much the challenge, and it affects cost efficiency, it affects energy efficiency. And so, this cartoon picture is there to represent like what's happened when we have lots of storage frames that are individually named and carefully curated, and they have, complex run books and people attached to the care and feeding. What happens is you end up with a lot of operational costs that can dominate what it costs to procure and power the actual equipment. And not to mention just be a drag on developer efficiency in deploying new applications. So this is a problem that we've really been thinking about a lot over the last few years in particular, is that macro, what happens at scale?
It's a little bit of pets versus cattle. Often that gets applied at a server layer. We talk about this like Kubernetes or containers, but it applies at a storage level too, just similar.
Absolutely. And so, one of the things that we've seen from customers that are deploying really large scale private clouds, and they've been doing that for 5 or 10 years, is what we often call the pod-based architecture, where say, okay, we might still have 20-30% of traditional estate that are special cases, but for 70-80% of the environment, can we standardize on some kind of cloud management system and have these pods that are maybe roughly rack scale or tied to racks of compute, storage, and networking, and have just simple, consistent APIs, very much like what you get in a public cloud consumption experience for the consumer of the infrastructure, but also to try to streamline the operations of what does it mean? How do I get out of the world where I've got 1,000 different special snowflakes of things?
We are thinking about this, though. Some
And
of it, yeah.
so
Continue.
to tie this into all the energy efficiency pieces we've been talking about here, right? We this is exactly like you mentioned, Andrew. This is we want to avoid having optimized the micro and miss out on the macro. We've got, we think, the most efficient storage systems. You can think of that as the micro. That's the individual building blocks that go into these pods. We've got to make it easy for customers to deploy larger scale collections, the full pod, if you will, without getting locked into something unique from Pure. We got to make it, possible for a customer to build a customized, management system that's unique to their business, unique to their workflows and requirements. And that's really the role that Pure Fusion, a relatively new product here at Pure. It's been generally available for a couple of quarters now, and we've got great reception early here in the market. What it does is it allows us to extend the cloud management APIs to the pod-based, the 70 or 80%, but also to places that might be more in the traditional estate, where you do still need a storage array with best-in-class, data management features and services, or where you can't deploy a full rack scale pod. Maybe you got kind of an IT closet for an edge site or an SMB location. We can unify that management plane for most things and, again, simplify the operations. And what that allows you to do, sort of full picture, is get the energy efficiency and the cost efficiency of all the way down to the flash and how we treat the hardware, but the operational efficiency of, I need to start thinking about my global footprint. And that's what this picture shows, is an example global topology where in a cloud architecture, I've got regions and availability zones, and I have different storage classes. I can't, as an operator of this, I can't be thinking about every single one of these storage arrays as individual pets. I need to think about them in aggregate and have APIs that allow me to manage storage volumes and the placement of them in aggregate. And that's exactly what we're doing with Fusion.
It needs to be policy driven. It needs to be infrastructure or storage as code. It's a buzzword, I know, but it means it needs to have some level of self-service. Even the idea of maybe consumers and providers, so people can consume the storage as people provide it. That's actually maybe some cloud concepts for at scale. So what's interesting is when we first started talking about some of this, I think you and I were working this out, Brian. I was like, let's think about how we actually handle both the micro and the macro. And Pure Fusion, I don't know, inherently, let's just be real, we're designed for energy efficiency. But if you don't have efficiency at a macro level, you might give away all the work that you did at the micro level. And that would be really painful to think about.
Exactly right. And, the great thing is just focusing on efficiency brings you energy efficiency, and it brings you cost efficiency, and it can bring you people efficiency, which is another way of looking at cost efficiency. And, so even if you're in the 37% that maybe energy efficiency wasn't yet a business focus, I'm guessing cost efficiency probably was. So it's an opportunity to have a real win-win.
So hopefully, we kind of wandered. We started with the topic, right? Energy savings, energy efficiency, gaslighting. Wandered all the way in through some context. Better science, smashing electrons through glass. Sometimes it's fun to write the titles here. I try to make sure they're still real. But I'm hoping that as we went through this now, when you see something like this from Pure, 84.7% lower energy usage. That's a dramatic number. And you hear us talk about, how we can deliver IOPS and density in one piece of equipment, and even some comments about how challenging to impossible for our competition to do that. These numbers, incidentally, are based on real comparisons that we did. Now, we can share specific details individually, but it's actually specific comparisons against competitors. We didn't just make these up. But I'm hoping that, frankly, even without sharing some of the specific numbers and the comparison stuff, what we went through helps you understand how this is actually really possible at a science level. And we didn't even hit on some of all the data reduction stuff that we do inside FlashArray. You alluded to a little bit, Brian. Don Kerouac went deep into that in the previous webinar that we alluded to. But I'm hoping this makes a little bit more sense. I think with that, we have come down the home stretch. We have a poll and we still have the drawing. Brian, thank you, as always, for being such a great guest. Any final thoughts to bring us home before we kind of let our hair down and go into Q&A?
I'll be sure to let all my hair down here. Thanks. No, it's always great to be on with you, Andrew, and great to see so many folks so engaged. So thank you.
No, thank you. So the last poll, if you don't mind going ahead and launching that, Emily, this is almost a little bit of us just figuring out that we're 2 years into this, and the response to this as a series has been phenomenal, frankly. And sometimes this is always for a technical audience, but sometimes it's like, do we go deeper? Do we hit on topics that are a little bit broader, even though they apply to a technical audience? Or sometimes even think about recovering engineers. You may be a CIO and you still find this stuff interesting because you want to understand how it really works, kind of thing, right? So we'll leave this open for a minute of would you like another session that goes deeper on these topics? So far, the absolutely is far away leading, and we'll leave the poll up here for a second. For the drawing, this is for an Ember mug retail value of $130, the kind you can control with your phone because, hey, that's cool. And it's actually kind of useful too. My wife uses actually ours much more to keep her tea warm for extended sessions. We're just kind of sipping your tea. Our winner today is Al Z from North Dakota. Thank you so much for joining us, Al. Please remember, we do have another next month, VMware and Pure. We're not done yet. I'll be joined by David Stamen. And with that, I think we're done the formal part, Brian. We made it through. And actually, I think we covered everything about as roughly as we planned.
Awesome.
I think I'll pull the music back up here a little bit. If it's too loud for people, let me know. And it's going to be a question. Maybe even first, Brian, I'll just toss it to you. There's always things you're thinking of putting in or not. Is there anything you wanted to add in? You were like, ooh, I got to keep moving. And I wish I could have spent a little more time on that. And then we'll do questions.
Well, so there's so much work that's gone into the software side of Purity for the last, it's actually 13 years that folks have been working on, how to engineer these flash-friendly data structures. And it's in some ways harder to talk about because there aren't physical pieces of, equipment to show off the way we can with the hardware. But there's a lot there that we've really put huge investments in and are very proud of, and amount to a lot of benefits for a customer, whether it's energy efficiency, operational simplicity, all the evergreen capabilities that if you've seen what we can do with a FlashArray or a FlashBlade, that actually ties back to technical underpinnings that go back 13 years and many hundreds of people working on what wasn't many hundreds in the beginning, but a lot of work.
Even some of that, some of it's just that you're building a platform that can refresh. We've done multiple hobby break sessions where somebody focused on evergreen, but we just keep orbiting around it because so much of what we do, and it takes all this engineering work to make it be true. Actually, it's just claims. Okay, so I'm looking through the questions here.
I'll pick one up. Nick had asked about future tech that may be taking the place of flash devices in the future.
Yeah.
And the short answer is we don't see anything in the next decade, which is about as far as anybody can, I think, credibly look forward in the media landscape that's going to take the place of flash. And in many ways, our bet on the future is that there's flash and there's tape in the data center. Hard drives, as more my personal belief, is not an official Pure Storage line per se, but I believe hard drives are going to go away. And I think they'll go away, slow at first and then all at once, as the saying goes. over the next really few years. And it's a lot of the reasons we talked about of you can cut the gap by building really smart systems at scale. And what's going to be left is you have flash for performance and capacity, and then tape. Nobody's touching tape for a long time in terms of the deep, 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 deep coldest archive.
I was on the partner landscape actually when I first heard the term flake. It's actually a term. It's a flash plus tape. So you can go Google it. It still feels a little weird to say it. I think it's more appropriate to say flake, but it's actually a term there for the idea of flash plus tape is what's going to be around long term at an industry level.
Let's see. So we also, and I think it's probably worth commenting a bit on some of the poll results that we saw. And I would say, not terribly surprising from my discussions with customers at all different, size organizations. There is an increasing focus on energy and sustainability, but let's also be honest, there are lots of folks, especially in the current economic climate, that are trying to figure out how do they get cost effectiveness. And if energy efficiency comes along with that, great, but they might not make decisions solely based on energy. So I didn't see anything that was terribly surprising, but that's also where you see us really looking for ways to, get both as positive outcomes. Can we, just by improving efficiency overall, can we gain a lot of the energy efficiency along with it? And as we look at how we design systems and a focus on energy efficiency, we also look at things, and this ties back to endurance. Well, one of the ways you can look at cost efficiency, especially in a TCO model, is how often do I have to replace the device? Right, in a spinning mechanical hard drive, I've maybe got 3 to 5 years expected lifetime. We can extend the life, even with QLC drives, we can extend that life out quite substantially. And that has TCO advantages. It also has huge impact on sustainability beyond energy, but sustainability, meaning we're digging up fewer rare earth, materials out of the ground. We've got fewer manufacturing processes. We've got fewer shipping containers that are moving stuff back and forth. But fundamentally, we got less cost going out the door of equipment to be installed. So it's another way to get that win-win while solving for some really important problems on the sustainability front.
And even this one, I think you kind of hit on this, but since Tim was kind enough to put a question in, he called it, striking result when you asked audience about sustainability. And he asked specifically about the difference between carbon footprint of enterprise disk and SSD or maybe flash. I mean, there has to be a huge difference there just from the energy consumption standpoint. More thoughts there?
Yeah, so there's, there are lots of ways my understanding is we want to look at carbon footprint all the way through the life cycle, from manufacturing to deployment to e-waste. And so again, I got fewer things that need to get replaced. I'm not burning, 8 watts of power per spindle to do nothing, because that's what you got to do with a hard drive. And so we're able to be more energy proportional during the life. We're able to have, fewer change cycles, as we have to replace fewer failed components. But a lot of the true carbon footprint also comes from being more efficient in all the things around the media. So if I have the right amount of CPU and DRAM and networking, and I say right, meaning it's proportional to the utility you get out. If you're building a tier 2 system, you don't want to stuff tons of CPU and DRAM that are going to be burning power and chewing up, carbon, spitting out carbon, when you're not getting utility out. And so efficiency is about proportionality to utility, and that affects everything in sustainability, but also cost.
So I'm going to take one here and actually go a little bit of a different direction from KG. I always try and leave last names out just in case. Pure's vision for 2023 for sustainability and reducing energy. I think you can read between the lines, or even explicitly, we've covered a lot of that. However, I also want to make sure to highlight, we actually have a ESG report. It came out in actually it says 2021, but it came out in 2022. It's highlighted there. That actually walks through literally our vision. It starts with a letter from our CEO. I don't think I could point to anyone better to state what our vision is officially for this stuff than our CEO, Charlie Giancarlo. I'll put that link in the chat for folks. So I would recommend looking at that because this is a focus. And as you mentioned, Brian, it's not just about the flash that you actually get that endurance to replace it. A lot of other areas. There was from Michael, interesting one about the energy trade-off of throwing more drives or more capacity versus deduplication and crunching down the data. Because it's kind of a trade-off of the compute versus the capacity. Mind elaborating there?
Yeah. So we thought about this actually from the very beginning because we don't want to do a ton of CPU intensive work if there's no benefit. And so we will, whether it's for compression or deduplication, live in the system in both FlashArray and in the compression we do in FlashBlade, we will sample data and figure out, is it reducible? And generally speaking, we've looked at this analysis, repeatedly as we've improved our reduction algorithms over and over and over again in releases. And in general, if it's possible to reduce the data, it's generally beneficial, but we have to be efficient in how we do it. And so we do that dynamically by sampling data and only applying the expensive, compute and memory to reduce if it's beneficial. We don't want to spend a whole bunch of watts and CPU cycles on doing that and then get a 2% return. So we don't.
There's three more. One's a little bit open, but I think we have time. One, I'll take a little bit of this if you don't mind, Brian. So from JD, how can one make the case for sustainability initiatives to senior management? I even think actually of Jeff, who's helping us out with the Q&A. He's very passionate about this topic. The thought, and I'm not going to try and boil the ocean. The one thought I want to go back to is what you mentioned, Brian, about how it can be efficiency, period. And so if you can drive solutions that are efficient from a performance perspective and a cost perspective that also have sustainability and energy linked into them, that's how you can drive it, right? So depending on your organization, you may not be able to drive it solely based on sustainability, but if you can align that to other areas, that can often be a path forward. That's frankly the one that I often see a lot, especially within the Americas, to be very candid, where there's that alignment.
And the other way to think about this is risk tolerance. We didn't necessarily a year ago, if we'd had this session a year ago, we wouldn't necessarily have anticipated some of the changes that came in Europe around the cost of energy and what's happened. And it's hard to predict some of these things. And so being a more efficient, having a more efficient architecture is also a way for organizations to have mitigated some of the inherent risk that may exist and simply unknowable risk and uncontrollable risk outside.
I think the last one I may just do is, and this is more maybe just a fun one to end with if there's a story that you want to throw in, but if not, this is from Venkatesan. Apologies if I'm getting your name wrong. What's the biggest challenge? I realize this, I don't know if this is meant to be a generic question, but sometimes like if you look back over 10 years, you've been doing this, like, what is something that you didn't expect that turned out a certain way? Unless I'm just putting you on the spot without enough caffeine. So.
Oh, no. There's anybody who's built large scale systems has usually a collection of fun war stories of specific, times when things were really difficult. But across the board, the thing that sticks with me is how we can draw those trend lines. We had those graphs of cost and, there's lots of these kind of trend lines and you can do the math, but sometimes you step back and it's hard to realize just what exponential growth looks like. When I started at Pure, the largest flash array that the team was shipping at the time, this was 2013, they had a huge party because we had a 30 terabyte raw storage array. Like the entire storage array could support a maximum of 30 terabytes. There are still t-shirts that we have that say, 30 terabytes, yay, because it was a big accomplishment. The largest flash module that we ship right now is 48 terabytes. Right? Think about that. And we put hundreds of those into systems, right? So the biggest challenge across the board is just keeping up with that kind of scale and all the things that you have to do to make systems successful when what you thought was big yesterday is all of a sudden kind of medium size and is going to be small in a couple of years.
build stuff. It's amazing. And then we build more. And we build more. It's like, ah. Thank you. I'm going to share the last poll results here for those who stayed with us. There is a pretty strong bent toward another session that goes deeper on this. So Brian may figure out the timing and have you back for some of the kind of better science vol 2, 3, and 4 that you've been thinking about.
Awesome.
As well, a final reminder for those who stayed us right to the end, which actually almost 1,600 of you. Please join us again next month. VMware and Pure, we are not done yet. Brian, we're right at the closing. Any final thoughts to bring us home?
Thanks, everybody. And thanks for hosting, but thanks, everybody, for great attention and awesome questions.
Appreciate it. Thanks all. We will look forward to seeing you next month. On behalf of Pure Storage, Brian Gold, this is Andrew Miller. Great month.